Okay, so let's take a look at problem number 8. Now, with problem number 8, it says that you have a gas with 110 kilopascals. Okay, so that is our pressure. So let's go ahead and just put P1 equals 110 kilopascals and 30 degrees Celsius. So we know this is a temperature. 30 degrees Celsius fills a flexible container with an initial volume of 2 liters. Okay, so our volume is V1, 2.0 liters. If the temperature is raised to 80 degrees, okay, so this is now a change. So we're going to put temperature 2. This is now 80 degrees Celsius. And the pressure increases. Now we have a pressure 2 increases to 440 kilopascal. What is the new volume? So our volume 2 equals, and this is what we are looking for. So you now have the combined gas law. So let's go ahead and write that down. The combined gas law is P1 V1 all over T1 equals P2 V2 all over T1. Okay, so we really want to isolate this V2. So what we need to do in order to isolate this V2, we have to divide both sides by P2. So if I divide here by P2, I have to divide this side by P2. Okay, so I'm going to do that. But I also have to multiply by T1. So T1 is going to be multiplied on top, so they cancel out. The P2s will cancel out on this side, so T1 will be over here. So what we really end up getting is our V2 equals, we're going to start off with this part of the problem, P1 V1 all over T1. All right, now, oops, that's a 2. Sorry. Okay, we are going to divide by P2, so P2, but multiply it by T1, T2. All right, so there we go. Now we are going to plug these numbers in. So all I'm going to do is I'm going to take this, boom, right over here. P1 is 110 kilopascal times our V1, which was 2 liters, 2.0 liters, times our T2, which is 80 degrees Celsius, all divided by T1, was 30 degrees Celsius, and our P2, and our P2 was 440 kilopascal. Okay, so what we see right away are degrees Celsius cancel, kilopascal cancels. Okay, I can see directly here the zeros cancel out, so 11 can go into 44 4 times. That becomes a 1. So what we end up getting on top here is we end up getting 2 times 80. That's 160 liters. Notice my only unit left is liters. All divided by 4 times 30, 120. And once we crunch this into the calculator, 1.3 liters is what we end up getting for our second volume. And so that's how you end up doing problem number 8 using the combined gas law.